Hello and welcome. I'm Bill Wake. We're working on an Elm interpreter written in Swift. We're going to work on the input and starting to do spaces and comments. Unfortunately, I did that episode but forgot or messed up something in the recording process, so I'm making another summary. I'll get better at this. You'll see. All right, so far we've been looking at literals in Elm, just the basics, just ints and floats. And along the way, we've done some work on parser combinators, some abstract syntax tree work, and some interpreters. Just a bare minimum kind of thing. All right, so we've got Elm float and a super simple expression that is I'm an integer literal or a float literal. And we've got these combinators matches one character or a string. Sequence matches a bunch of things in a row. Any of is the optionals. Um, well, it's pick one of these. And optional says this one may or may not be present. Many one says one or more. And combine says given a bunch of parsers, I can combine their values together and make a function that returns on that. So what I wanted to do was working with a character view, which is an array of characters. Um, well, there's complication there, but basically work with an array of characters instead of a string, and then do spaces and comments. And I did a lot of stuff that I undid today, so maybe it's best that we have this summary after all. All right, the first thing we did was we looked at the situation with floating literals, and we found out that if you do something like 3e4, that's also a legitimate floating point number. So you can have 3.2e4, 3.2e minus 1, things like that. But 3e4 is a legitimate float. And our grammar didn't accommodate that. So we basically, the start of the day, we made this part work. So we changed the way float literals match. So it starts with a character, a series of digits, one or more digits, and then you have two choices: the sequence or a sequence. So you can either be a period, more digits, and then an e plus or minus digits, or you can not have a period and just be e plus or minus digits. Now, at one point, I just tried to make the period digits optional, but then you look like an integer, so we can't have it all be optional. So I think there's better ways to write this, but we'll get there. Okay, so we supported that pretty quickly. Then we tackled this notion of the parser and the input stream. I went down the path of making this an array of characters and trying to deal with first and drop first. There was something messed up in the way this rest works. I'm not sure what caused that. And I don't know, we went 20 minutes or so on that. At the end of it, I just wasn't happy, so I reverted it and went on to something else. Okay, that's the way it goes. Um, I've got enough to do that I don't want to be stuck on any one thing too long if I have something that works now. The current way works is just potentially relatively inefficient because as I create new inputs, I copy these strings around potentially. Um, Although I don't know, maybe it's not as bad. The real challenge is in a string, because of the way multi-byte characters and all that work, it can be really expensive um, to isolate a character, and so pulling out the whole array can be faster if you do that in the first place. But we have to watch that we don't copy arrays around. Strings, I think, are pretty good about doing substrings and stuff like that. But again, we have to allow for it. So anyway, I took a stab at doing this, didn't like the result, and backed it out. All right. The next thing we did, we have these methods sequence. Okay. We used to have a method that was any of, and any of took a list of parsers of returning a and produced a parser returning a, and it does that by checking the selection. So let me see if I can bring up an old a diff. Um, that's not the one I want. Can I go back? Let's Let's try a different way. Let's do this thing. Okay, yeah, here's that. Okay. Add index. All right, I'm just going to back it up and we'll just look at the old way. So parser.swift, let's get down to the any of. Okay, so here's any of. It takes an array of parsers returning A and it returns one of those parsers. Which one does it return? Well, it runs through all the parsers until it finds one that actually matches its input. And when one is acceptable, it returns that one. If none of them are acceptable, it just returns, it's a parser returning nil all the time. It just says, I don't know how to do that. Okay, and what I did was I changed that into an operator. So the struggle I have, and I haven't solved it yet by any stretch, just in this one case, it's this thing of parser of A versus parser of array of A. And like down here, optional takes a parser of array of A. But it would be reasonable to define optional to just take a parser of A and produce a list of 0 or more, 0 or 1, okay? And here we struggle. We have two sequences. One takes parsers, an array of parsers of A, produces parsers of array of A, parsers producing arrays of A. Another one takes parsers of arrays of A and produces parsers of arrays of A. Parsers producing arrays of A. So it's confusing to say and it's confusing to think about. And when you start mixing and matching these things, it also gets confusing. So lots of ways I get confused. But what I did do was I was able to take that function any of and turn it into this bar. And I chose the bar because that's usually the way we write grammars. And it's already an available operator in Swift. And the compiler liked it okay, so that's why we chose it. So with this one, we're only going to worry about two parsers, not the array of parsers I showed you just a minute ago. You just take two parsers and one or the other or neither can pass, okay? And we can get the value we need from that, okay? And then you can use more than one of these because the result of the first one, it's kind of an associativity thing. The first A or B or C matches A or B first, and the result of that is a parser. Well, that parser can be that or C, and so it basically attempts the values in order still. That's cool. And so I thought, oh, well, this is good. I'm moving forward. So let me try and make one that lets me do an ampersand to represent appending things together. Some languages use that, ampersand for that. And it's sort of like Boolean arithmetic with ampersands and or bars. This is the same thing in grammar terms. That's basically what you're doing. You've got I mix these things up. Is it a group or a ring or what is it? But the abstract algebra thing escapes my mind. I think it's a ring. You have two operators, plus and star, basically, that may be more than just simple multiplication of numbers. And if you have those two operators, you've got things you can define and things you can do. And we're looking for that in our parsers. So I tried defining something, I did define something that takes a parser producing A's and another parser producing A's, and it gathers their data into an array. So it's a parser producing an array of A's. And basically, if you parse A then B, you want the array to have A for the first element and B for the second element. Where it got messy is back to this thing about arrays of A's. So if I parse a sequence of a sequence, well, the first one is returning array of A's, and the second one's returning array of A's, but now I'm returning array of A's, and it gets tangled. Now I may find a way Well, I'm sure there is a way to do this better and make this not an issue, but I'm not there yet. I'm working on it. Okay. But my hope would be if you could write your grammar. Let's go back to Elm Parser. I would love to write my grammar with match dot, you know, so let's see, this is a sequence or a sequence. So match many digits, then match dot and match digits and optionally match the exponent. That would be nice. And it would be an improvement. And I hope we get there. But until I figure out this thing of how do I know, okay. And the challenge is like match produces an array of things, optional produces an array of things, many produces an array of things. But if we only supported lowercase e, it would this match well, character is digit, say. It only supports a single digit coming back. It's a character. Many one turns it into an array. And so we're going back and forth, and things keep appending too many arrays on it. I'm sure it's a simple solution, and once we get it done, it'll be like, oh yeah, why did you struggle? But you got to know who you're dealing with here. I'm going to struggle on some of these things. All right, let's see. What else did we do? So I would say that stab at improving the parser sort of worked. The or works. The and I don't think we're really using it yet. I tried using it up here with with matching sequence of parsers, but it got tangled up in extra parentheses again, and I wasn't happy. Um, we'll try. We'll see. Okay. So anyway, I'm sparing you about an hour of stumbling around on that. It's good. I'm learning things, but yeah, it didn't work. Okay. Then let's see. We went to spaces. So the way Elm uses spaces, I haven't fully untangled, but I know you can have spaces in front of things, and you can have spaces up to a new line after things, but you may need things on a separate new line. So I don't know. We're just going to match spaces. So we defined a new parser. I mean, we sort of wished it into existence, spaces. And what it does is it does many or more, one or more spaces. And once it gets them, it puts them into uh, our AST, abstract syntax tree, which isn't very tree like yet. But we created a new category for Elm ignored. And this is because when you're combining things, you kind of switch domains. You start off in a character domain, you get into a parser domain, you get in, then you get back into characters, and you want to get into the AST domain is where you want to end up. And so, like here, combine converts us from a array of characters into, well, a constant ignored, which is fine. And at some point, we have to figure out how to make sure the right things get ignored and when. In a lot of languages, this spaces get dealt with at a lower level. They call tokenization. Usually, you can do it with regular expressions. You peel off the spaces and ignore them, and only return the interesting tokens. Elm appears to have rules around spaces that are more complicated. So I know for sure, at least in the documentation, it says if you have a case statement, I think your subcases have to be at the same indentation level. So there's stuff going on here that cares about spaces, and we proved that. Let's see if I can get to Elm. Okay, Elm REPL. So we proved that you can say this. You can put spaces after it. But if you think you've terminated it, that's one expression. Here's another one. It's like, no, 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 something's wrong. So there's definitely rules about what goes on and how it's there and how it's separated and all that stuff. So I'm not going to pull in the new lines just yet. We may do that at some point. But for now, my next code again. Oops. All right. for now, we're just going to match on one or more spaces and just get those things out of the way. I think we could probably pull tabs or something like that at some point too, but this is where we're starting. And let's see, when I did this, I guess you're going to get the preview because where we left off, it was not working. Where's Elm Parser? I had I had it like this and run tests, and some tests are going to fail. At least the space test. I don't think anything else can see this variable yet. All right, so while this is running, uh, the punchline is going to be we have to actually match a space character. You can't match an empty string, and that's partly we have match defined to either take a function or a string that it peels apart into characters. This would say just match nothing. It's fine. Okay, and you know, so what you see or what you don't see is basically we're stuck. Okay, yeah. So it runs some tests, but it's starting space comment tests, and it's just sitting there, and it's going to keep sitting there. So let's stop it. Oops, stop. And put this in and run them again. And that passes. So don't be surprised when it works in the first 5 minutes next time. So next time is Tuesday. Let's see, the 12th makes that the 19th of January, 1 to 3 p.m. Eastern Time. So thanks for joining me. Hope to see you again. Bye bye.